So we're going to start thinking about forces by firstly showing you how we represent forces on an object. It's very simple. You represent a force on an object by drawing an arrow. Now, the length of the arrow can represent the size of the force. So just double check any question that you're answering as to whether it wants the arrows drawn to scale or not. But obviously the direction of the arrow represents the direction of the force. Remember, force is a vector, so it has both a size or a magnitude and a direction. One thing we're going to look at in this lecture is calculating a resultant force. That's a force that's left over in any particular direction in an object, which will tell you about how that object is going to move. There are two ways to calculate the resultant force of an object. If any forces are acting in the same direction, then you add those two forces together. But if the forces are acting in opposite directions, then you subtract one from the other. And this will allow us to calculate the total force that's left over in any particular direction. So we'll apply that to the example of the car down below. So we're going to say that there is a force of 100 newtons acting to the right and 80 newtons acting to the left. The resultant force in this case would be 100 newtons minus 80 newtons. Remember, we said if they're acting opposite directions, you subtract one from the other. So we'd have a resultant force of 20 newtons to the right. That means this car is going to accelerate to the right. If we now look at the vertical forces on the object, and we have 1000 newtons of the weight of the car, and we have 1000 newtons reaction force to the floor on the car, we can see that the resultant force, because again they're opposite, you subtract one from the other, so we'd have 1000 newtons up minus 1000 newtons down, doesn't matter which way around you do it, you would get a resultant force of 0 newtons. That means there's no upwards or downwards force left over, they're balancing each other out, so the car isn't going to accelerate upwards or downwards. So in this example we would say that if there is no resultant force, then all the forces on that object are balanced. However, if there were a resultant force, so for example, if we go back to our horizontal forces, and we now have a resultant force of 200 newtons to the right, then we would say that those forces are unbalanced. So we're going to look at an example of a diver here floating along with a little propeller. So we're going to look at the vertical resultant force first. We can see we have an upwards force of 950 newtons and a downwards force of 900 newtons. So we've got up thrust and weight. So to calculate our resultant force vertical, so I'll just call it RV, we have 950 minus 900, which equals a 50 newtons force upwards. If we want to look at our horizontal resultant force, we can see we've got two forces here going to the right, one from the propeller and one from the flippers. We've got to add those up, remember they're in the same direction. So we'd have 100 plus 30, but then we've got to take away this force over here because it's in the opposite direction, minus 50, and that would give us an 80 newton resultant force to the right. Remember, we need to specify the direction because force is a vector quantity. So that's how we show forces, and that's how we would calculate resultant forces.